I'm not late to the contest. I have 1 hour I'm 1 minute 45 seconds early. It seems. Do I have everything ready? Someone wrote this song before, and I can tell you where it's from. The 27465. My screen is being shared, and my voice is also audible. Yeah, everything's working fine. Do I still have some people looking up for my videos? Do I still have people that will watch this video because I haven't been streaming for a while now, right? Do still people enjoy? Do people still enjoy? Is there anything to enjoy in what I say for that? Someone wrote this song before, and I can tell you where it's from. The 27644. Wow, so cool. Please don't There are n piggies standing in a line number from 1 to n from left to right. Each piggy is either facing left or right. Two piggies x and y are called a watching pair. If x less than y, x is facing right and y is facing left. You're given an integer case as that a piggy is called self if it belongs to at least k watching pairs. Your task is to make all piggies safe. To achieve this, you can choose any number of piggies and flip their directions. Compute the minimum number of piggies you can. You need to turn around so that every piggy becomes safe. Okay, there are multiple complexities to the problem, but it's an easy problem because it's A, so you have to think of a bit easier solutions. Mm, what does that mean? If something is right facing, it should be at least k watching pairs, and k is greater than or equals to 1 means it gives some immediate necessary conditions. The first one must k greater than or equals to 1. If you see, the first one must be right facing. Okay, the first one must be right facing, and the first left facing should come after at least k hours, and then the same you can say that at the end there should be at least k hours before the first, k else before the first hour. So these are the two conditions, and if these two conditions are satisfied, everything else will be satisfied because everything else will be satisfied. So that's just the problem. It's at least, I thought exactly k because it's at least, that's just the problem. That's just the way it is. And this also says that 2k should be less than or equals to n, else it's impossible. Someone wrote this song before, and I never. S of I not equals to r. S of n minus I minus 1 not equals to L. Only this should be flipped. Someone wrote the song before, and I could never could tell you where it's from. Given an array of n integers, your initial score is 0. You can perform the following two types of operations any number of times until the array becomes empty. You have two type of operations. You can do them any number of times. Your initial score is 0. Choose a single element, add its value to your score, and remove it from the array. So take it to score. Choose two adjacent elements, add the maximum of their values to your score, remove both elements from the array. This operation requires, so there are negative integers, the array to have at least two elements. So yeah, so yeah, first operation is nothing. Second operation is you can remove one and then you can take one. Okay, you can remove the smaller one. This is the second operation. So if you see from the total sum, it's all about what all you will remove. The final score of yours is okay. Because C is a bit complicated, immediate guess should be you will likely brute force number of operations. Okay, maybe you will likely brute force number of operations. Then you can imagine the final score to be like just minus k times c, where k is being brute forced. That's a simple thing. That's fixed because otherwise you cannot get a simple solution. That's fixed. And once that's fixed, now think about it. Let's say you're doing k operations. What's the best thing to do? If you are doing k operations, how many elements will be removed? K elements will be removed. Okay. Okay, we have to think a bit. You can always take the okay, here you remove both the elements. So you have positive values, you have negative values. Positive ones will always add up to the score. Or maybe greater than or equals to C matters. Maybe that also can be there if you're not brute forcing. Because anything less than or equals to C is bad, right? There's no point of taking that because to remove that, to add that to your score, you will definitely have to subtract that. But anything greater than or greater than C is good to add to your score. So let's say for all the things that are greater than C, you will just take them, add, take them, add, take them, add, take them, add, take them, add. And now for the things that are less than C, why do you even want to take that? So it's just the answer sum of greater than C minus C. Oh, we have to perform this until the array becomes empty. I haven't seen that. We have to read the problems properly. I thought I can stop at any moment, but then just seeing these test cases reveal that we cannot stop at any moment. And here you can only choose to adjacent elements, but adjacent elements always exists, right? Okay, you have to go until the array becomes empty. Adjacent elements always exist. So let's see them as greater than C and less than or equals to C elements, okay? Now, as long as there is something which is less than or equals to C, yeah. So you have less than or equals to C elements, and you have greater than C elements. That's all they are. So to remove, you can just simply take the maximum ones one by one, greater than C ones, or you can always use it to remove one of the smaller thing, right? Okay, you can definitely do that. And then if the number of smaller things are like less than or equals to this thing, you can remove all of them. So which is very fine. But if number of smaller things are much bigger, then what should you do? Then you can only remove these many things and then you will be left out with them. And once you are left out with them, you can again split half. You can always color greater than or equals to half maximum things as one color and less than or equals to half things as another color. And then in that case you can always do that where negatives or like less than c things are much bigger. In that case you can just color greater than or equals to things as this color and the less than or equals to this as this color, and then you will say you will take all of this as the operations because that you can always do. Someone wrote this song before and I can tell you where it's from. So that's the cases, I guess. If this count is less or less than or equals to this, you have answer equals to sum greater than or equals to cg minus c. This is the maximum you can attain. But if this is the case, I think you can always make sure that you take the uh, top rightmost thing, because if you paint them red and if you paint them green and if you paint them red, there is always a red green. You can always remove that red green. Like it's order doesn't matter much, but once you know how much you can pick out, how many you can pick out, and this is the minimum number of things you can take, and you're taking the positive things into the score. You can't take less than them because you have to remove the things, right? And removing you can only do once. So it's quite obvious. So now it is about start from Okay, if there are n equals to 2, this will become, I'll just do n minus 1, n by 2. If I equals to 2, it will become 0. Oh, no, no. It should be n plus 1 by 2 itself. If I equals to 3, it will become 2. I think it should be n by 2 plus 1. See, I want to start from floor plus 1, which is n by 2 plus 1. It's just n by 2 then. Because for 0, 1, for 0, 1, it should be 1. For 2, it should be 1. And for 3, it should be 1. So, yeah, that's all. Someone wrote this song before. That was a weird struggle. It's an easy to guess, but I have also proved with using colors, right? With red and green colors. Someone wrote this song before, and I can never. You're given a positive integer n and a non-negative integer k. Construct a permutation p of length n such that the following condition is satisfied. Let f of I equals to max of some prefix for 0 less than or equals to all of them. Then f of 0 XOR f of 1 XOR f of 2 up to so on n minus 1 should equals to k, where XOR denotes the bitwise operation. Note that a permutation of length n is an array consisting of n integers, for example, is not a permutation. Minimum excluded element. What happens to the mix of prefixes? It will stay 0, 0, 0, 0, and then it will become 1, and then it will become 2, and then it will become 3. Oh, wait a minute. Yeah, 0, 0, 0, 0, and then it will become 1, 1, 1, 1, 1, and then it will become 2, 2, 2, 2, 2, and then it will become 3, 3, 3, 3, 3. Or no, 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 wait a minute. It can jump to some other value, and then it will stay at that value. And then when a new element comes, it will jump to some other value, and then it will stay at that value. And some jumps will become even, and some jumps will become odd. Okay. And you have to construct the mix. So maybe it depends on the value k. Because k is XOR, one thing is sure, it should be less than or equals to 2 times of n. Otherwise, it's impossible. But whenever it is less than or equals to 2 times of n, maybe you can construct one thing. If k is less than or equals to n, maybe you can just make n itself the answer and then everything else occurring at the end. But yeah, one thing is sure. F of n minus 1 is known. F of n minus 1 is n. But except for f of n minus 1, maybe everything else maybe everything else you can fix except for n minus 1. Yeah, everything else you can fix. I can see a series of things where everything else will get fixed. What is that series is? Let's say you want k to be odd number of times. Okay. One obvious thing is k less than or equals to 2 times of n, because you cannot do more than that by using smaller things. Okay. And I can see the other thing. Other thing that is good is like f of n minus 1 equals to n always. Okay. So you gotta do n XOR k, and then this is what matters. But yeah, let's just call it k for now. Let's just call it k. How much screen is this one? And if I'm calling it k, someone wrote this song before, and I can tell you where it's from. Okay, if this matters, I have some other configuration. Okay, let's say I want to force a value k. Only here, and then k plus 1 will never occur. K plus 1 will take the last position. Okay, and k will be the value everywhere. Only at the end k plus 1 will come and then the XOR becomes n. So I have this value k now. And then what I will do is I will put 0 here so that everything before is 0 and nothing else matters. You can keep, if you just preserve these three ordering till here, it is 0. And after here, you will definitely get 1. So at first 0, 1 will become XOR. At the last, at the complete suffix, there will definitely be m. So 1 and n will be there. But after that, I can just make it, see, I can just make it k. Don't you notice how I get quiet when there's no one? Oh, we'll keep it k minus 1 here, k here. So here it became 1. And immediately after that, it became k minus 1. Max will become k. And then max will remain k, 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 k until the end. Now, only duty we have is we have to make sure that this is odd. Actually, all you have to make sure is 1 to k minus 1 elements. The starting 1 to k minus 1 elements. After 0, okay, 1 minute. But if after 0, if there is 1 here, you will again have the complexity of having 2. So let's just put all other things here. Okay, let's just put all of them here. Now it's very clear that if there is one more element here, you can just swap them to make it odd or even. So to have one more element here, what does that mean? To have one more element here, to have one more element, how many elements have we used so far? 0 to k, k plus 1. So if k plus 1 less than, you have n elements in total, n. And what is this k? This k is after removing n and 1. Then you are done. Answer is yes. And it works. It just works. What if it perfectly matches? Then even then it's done. Because even then only here you have odd number. It works out anyway. Because you got k and then you have the other thing. So yeah, this worked. What is k here? K equals to n XOR 1. This is the value we worry about. This value we worry about. And this value should be less than or equals to 2n. And if it is less than or equals to n minus 1, we are done already. Someone wrote this song before, and I can tell you. What do I mean by 2n though? What do I mean by 2n and n and everything? Let's say this is the leading bit in n. We would like to get everything in between these two things. Okay? But I just got that everything less than n can be achieved. Whatever the n minus 1, like whatever the n values are here, if you subtract minus 1, all of them can be achieved. Let's just keep it simple that let's just assume that all of these can be achieved. All of these can be achieved. Let's just assume that thing. Okay? N is somewhere in between. Let's just assume that all of these things can be done. How do you assume that? So you have this 2 power, right? Let's utilize this 2 power and let's treat other things as less than or equals to n, because if you remove this 2 power, that will definitely be less than or equals to n, right? So let's see in that fashion now. So we have something less than or equals to n. You know how to make that work. And then now if I can just bring this up, which is greater than n, if I can just bring that up once, then I'm done. Right. So let's think about the same pattern. Let's say it is just equals to, like, let's say your k equals to 2 power, let's call me b plus z. Okay. Now what I would do, 1, 2, 3 up to so on, z minus 2, 0, z minus 1, and then we have z at the final. So what this makes is z is definitely less than n minus 1, because we are leaving a 2 power. N minus 1 is definitely less than that. Someone wrote this song before, and I can. For k equals to 0, we need not bother much. That is a bit simplified. For k equals to 0, you just have to put 0 at the end. That's all. Oh, wait a minute. I think I left my consciousness in. Wait, my assumption that 1 will come is wrong. The first time 0 comes, here itself you will get k. Fuck, what have I done? Here itself you will get k. So this is wrong. This is true. Now you want, yeah, you want one more element to be present here, which comes this side and makes this again k, odd number of times. There is one more element here, you can bring that up here and then you're done. So there is no 1 actually. Sorry. N is the only mandatory one. I should have been careful, I think. But yeah, if there is one more thing, you can just bring that here and then you have changed the parity. But if you're not able to change the parity, then there is nothing here. And if there is nothing here, that means it is already odd. That's what you want. That's also done. Okay. Now where am I? So you have Z. You want 2 power B now. Now you want 2 power B. What do you do? As long as you miss this Z, it will stay Z, right? So what you will do is you will fill everything until 2 power thing now. Z plus 1 up to so on. 2 power B minus 1. Okay? There can be a simpler way, I think. I have to do it a bit faster, I know that, but someone wrote this song before. I can tell you where it's from. This is not that complex. This should be doable. Okay, after this, now you can place 2 power b. Now if you place, wherever you place z now, there you will get, there you can get 2 power b. So what you will do now is, you will place z here, and then you will place 2 power b minus 1 at the end. So now you have 2 power b. Here you have z. And then you have z to 2 power b. From here you have 2 power b. So you want both of them to be odd. Okay. How can you make both of them odd? If there is nothing here, here it became 2 power b for the first time. If there is nothing here, then this is already odd. Okay. And will there be nothing here? If you think about that, these are just z elements, which is definitely less than 2 power b. These are 2 power b elements. So there will definitely be something here. And then what you do, you can flip that here so that you have, this is non-empty. So you can definitely flip that here so that you can make this length odd, and then this will also be non-empty. If it's empty, that's fine. If it's non-empty, you can just flip one more time. So that's all the solution is done. Someone wrote this song before, and I could tell you where it's from. So what I will do is, I will check if this bit is active. Then what I will do, I will place 1, 2 up to 7, z minus 1, 0. And then I will place the remaining things, and then I will place z. And then I will place the remaining things, and then I will place 2 power b. Done. Now what will I do? I will check after this how many jets are there. If it's coming odd or even, then I will just flip, I will just add one onto this side. And I will again check from here how many of these things are there. If it is odd, then I'll just swap this ones to this side. That's all. Because I am proven clearly that this will definitely be existing. This will definitely exist because z will be far less than 2 power thing, because that cannot be, it's definitely less than, at least one less than that. So yeah, and then I'll flip it, and then I'll flip it. Like from back, if it is in the odd position, then just flip from back. If it is in odd position, then just flip it. Done. And in the remaining cases, when this bit is less than that, then the other thing itself is done. Then just this is enough. This is done. So we have two cases. How should I do them? K less than or equals to n. Yeah, problem is done though. Someone wrote this song before. So we have the highest significant bit. And once we have the highest significant bit, what should we do? I want highest significant bit in n. Okay. Now, okay, we have these many bits, right? If I left shift this much, and then if it is greater than 0, that means you fucked up. B is index, that's why I made it like that. B plus 1 bits. If you just left shift, Now what? If this is active, what will you do? Else, what will you do? Someone wrote this song before. So what I will do? 1, 2, I'll just keep z equals to k minus of this, or you can just do XOR. Now what will I do? Till z minus 1 and then 0. If z is 0, even then it's the same thing, I believe. If z is 0, then we have 0 here. Let me think about that. If z is 0, what I will do instead is I'll just put all of this before that and then I'll just put this there. That's all, right? But if I handle I think if I handle the other case before, if k less than or equals to n is handled first, then I need not even worry about this thing. I'll handle this first because that is less than or equals to n anyway, so I need not worry about that here. Now what will I do? I have to think about the first case. 0 up to so on this, yeah. 2 power n will be, 2 power b will be handled here, so I need not worry about that. Someone wrote this song before. 0 to k minus 1. Keep p of I equals to I plus 1. And then you have to keep p of k equals to, what is this index? K minus 1 elements, which means this will be index k minus 1. And then you have to place 0 there. So from k plus 1 you have to place the remaining things, right? So now where is k? K is over here, right? K is over here. First time k is occurring at index 0, 1 up to so on k minus 1. So from k minus 1 to n minus 1, how many things will be there? If n minus k remainder 2 means number of things that are in between these two, including this, if that is even, that means you have even number of things, means you have these are even, you have to just swap this, will just handle it. And here what should I do? I will just keep int z equals to k minus of 2 power b, and then what will I do? Z is greater than 0, I need not worry. 2 power b is also completely greater than 0. I have to start from 1 to z minus 1. Okay, I will put this place. This place is like z minus 1 elements are there, so that is z minus 1 index. So first I will do p of z minus 1 equals to val. And then I filled this, and then I will fill from, and then I will fill this one. What is that? You have 0 to 2 power b minus 1 things. Hey bro, what's up? Yeah, I'm quite free, but I'm giving a contest till 10:45. No, it's not that important, I think. Say what you can. Yeah, I'm streaming, but even streams are not that important. I guess I'm not doing them. Yeah. Okay, sure. I'll be free at 10:45. I got biometric. I can come out anytime. But yeah, we'll meet tomorrow. Bye. Someone said this. So these are 2 power b minus 2 power b elements, which means it's 2 power b minus 1 index. Mm-mm-mm. I'll just name that index as int idx equals to 2 power b minus 1. Okay. Now you have to put this equals to val plus plus, because that's where z goes, and then you have to start from z I less than idx I plus plus p of I equals to val plus plus. Now I'll try to do two swaps. Now we have to fill the remaining things. Did I fill the remaining things here? I have done. I have done filling the remaining things. Someone wrote this song before, and I can tell you where it's from. The 2 power b will go to the end. Someone wrote this song before, and I can tell you where it's from. Now, if n minus 1 minus idx from there to here, if this is even, that means this is odd. Okay? You have to do, if this is even, you can just do swap of p of idx comma p of idx plus 1, and then if if after doing this, if after doing this, if idx minus of z minus 1 is even, swap p of z minus 1 with p of z. Someone wrote this song before, and I can tell you where it's from. I hope I didn't make any mistakes here. It's not a difficult problem, but yeah, idea wise, it's not difficult, but it has some implementation in it, I would say. What have happened here? Okay, if k equals to 0, then if k equals to 0, I'm assuming that there is 0 at the end, right? But I have some logical issue, which is when k equals to n, you cannot place k anywhere. That's the issue I had. Okay, if k less than n, then this works because k minus 1 is a actual value. Oh, wait a minute. You don't even have, even when k less than n, this won't work because I think there is some corner case over here. I think there's some corner case over here somewhere. I can't get stuck on C. What is the corner case? Like, the thing is, This value k. 1 minute. What am I doing? Nothing, nothing. I'm doing fine. I'm doing all right. Okay, if this value k is less than or equals to n minus 1, let's say, then this value exists and everything else is fine. Yeah. What if k equals to n? Then this will break likely, because if k equals to n, you cannot place this thing. If k equals to n, yeah, that is breaking. Now you want to achieve n. You already have uh, you want to achieve XOR n for all these prefixes combined. Only k equals to n is breaking me. And for k equals to n, if z is greater than 0, this will handle it. But if k equals to n and z equals to 0 is the thing that is annoying to me. If k equals to 1 and z equals to n, yeah, that's the annoying thing. K equals to 1 and z equals to n, you have to make it even. Okay, that's the only thing that's left here. K equals to 1 and z equals to n, because if z is equals to greater than 0, okay, now k equals to n. If now it's possible that z equals to 0, if z equals to 0 means k equals to n equals to 1 power b. This is the only case I'm worried about, because if z becomes 0, it's a bit worry. Before it, I thought it's not possible, because I've just seen that k must be greater than n, and which means like it is greater than 2 power b. But now it can be equals to 2 power b. Only that case we have to handle here. Okay, how to handle that case? I think it can be done, because we just have to make them even. Because if we are able to make them odd, we can also make them even. But can you activate this bit? Can you activate that bit? That that bit cannot be activated, because that bit cannot be fucking activated. It will only activate once. You can't activate it again, because it will only come once if everything comes. All other things are smaller bits. With smaller bits, you cannot create what you want, which is this value. That's a weird, no? Should I submit this? Is everything is working as expected? Let me just submit it. Fuck, I took quite long on this. I hope at least it gets passed. The fuck is happening here? What is k here? K is 0. K is 3. Right? And what I have done for 3? We have 0. K is 3 and z equals to 1. So what will I try to make? I'll try to make 0, 1, 2, 3. Sorry, 0, 1, 2. I'll try to make this. I'll try to make this because these are not there. Before 0, you have to keep z minus 1, which is done. And then you have to keep z here, which is done. From z plus 1 to that, it's done. And then you have to keep 2 here. So what has gone wrong? Oh, wait. This is n minus 1. Now, all of these also should be permutations, but they're not being permutations. So, what's wrong? Elsewhere, have I done the same mistake? Okay, now it's coming in this path. K is 1, 5 is 4 plus 1. So, here, K will be 4. And what do we do for 4? What do we do for 4 is, this is the pattern, right? What do we do for 4? We keep 4 here. And then we do 1, 2, 3, 4, 1, 2, 3, 0. This is what should have happened. Oh, okay, I thought I will overwrite it, but then I have done that fucked up. I thought I will overwrite, but then I was not overwriting. I was using val plus plus, which is a wrong thing to do. But what's cooler is if k equals to n equals to 2 power b, that was cool. Yeah, that was cool. It's quite simple. You cannot have XOR. I'll break the laptop. Fuck. The fuck? I handle everything right. Except for that, everything else is possible. Okay, okay, okay. No, 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 no. I'm writing properly. I should quit CP. This is correct. What about this? This is also should be correct. And now what about this? K less than n, which means it will be among one of the values. You'll just keep it here. It's greater than 0. This will also work. What will you do after this? If there's nothing here, it's already odd. If there is something here, you can just flip it. In this case, from here till here, how many values of this are there? This index is idx, and this index is z minus 1. So from here to here, if there are odd number of things, you'll surely have something bigger than z and less than 2 power b. Wait, will you surely have something greater than z and less than 2 power b? No, actually, not actually. Because if z equals to 2 power b minus 1, then no. Then you don't have anything here, if you see. In that case, you have to be a bit more careful one more time. Because in that case, if you see, there's nothing of this here. And then what I'm trying to do? I might be trying to swap these two things, which will mess things up. Right. So I have to be a bit more careful of that now. Okay. Z is greater than 0. Z is 2 power b minus 1. You have to just solve this fucking case now. Is it solved already? Think of it. If there is nothing here, it is odd already. So it is solved already. Yeah, it is solved. Why are there so many things to verify here? I'm able to verify, but why is it an error? If there's nothing here, then it's already odd. From here to here, it's already odd. But if there is something, okay, now if you flip and then something else came here, now it became odd. What have I done? 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 Yeah, when I say I have to check now, I have to check now. What the fuck was I doing? I was trying to compare with this IDX, right? I was trying to compare with the new IDX, and without doing IDX plus plus, how the fuck will I know that? I've told many times that I have to compare it now. I have to compare it now. But if I don't update the index, how am I comparing it with now? That's so stupid. Like I told so many times that I have to compare it with now. Like I have to compare after doing this swap. I have to compare, but after doing that swap, this index will change, and then you have to compare. Fuck! I have to control my anger. I guess I have anger issues these days. Thought you were too good for me, my dear. Never get the time of day my day. It's okay, things happen for. It's quite simple. If 2 power B is occurring even number of times, that means you can swap one. And now again you're comparing if it's happening even number of times, you can again swap one. Oh, wait. Doing these swaps is risky. Is it? No, it's not. Because if you keep k plus 1 here, it doesn't matter, right? Because z is not gonna come. It's perfect solution. Wait. Z0 doesn't mean it's impossible. Yeah, this implies k equals to n because if k less than n, it might have been handled here. This is bad. Why? Why am I getting wrong answers? I have been a bit careful, right? Why am I getting wrong answers? Because if k less than n, we are done. If k less than n, we are done. If z equals to 0, which means if z equals to 0 and k greater than or equals to n, is k greater than or equals to n? If k is actually greater than n, that means k that has that and then it's greater than that. So z cannot be 0, means k equals to n, and then it's no. Yeah, maybe there's an easier solution, but this is the easiest solution, right? It's the same pattern. See, 0 to z minus 1, you fill it. You fill z minus 1, and then you fill 0 to z minus 1. And then you will fill idx, and then you will fill z to idx minus until idx. And then you will fill n minus 1, and then you will fill idx after to here. Those are not matching. So many people are solving it. Let me try d1 and then I'll come back. Done it right. Wait, idx is having 2 power b elements here. Z minus 1, 2 power b minus 1, n minus 1. All of them make sense, right? Perfect sense. So annoying, everything is so perfectly fine. Should I add more assertions? 0 to z minus 1, z minus 1, idx, z 2 until idx plus 1 until n minus 1, n minus 1 until n. 10,000 on my thing. So annoying. This is the easy version of the difference versions is that in this version, N is not a question and m question and n plus 1 by 2. You're given two integers n and m, you need to construct an integer array of length n that satisfies m restrictions. Each restriction can be represented by tuple O, Y, I, J, such that O is less than O belongs to 1, comma 2 and I, comma J. Okay, restriction if O equals to 1, sum of must be non-negative, and O equals to 2, then sum must be negative. So you have to construct an array, and you have a difficult version too for this problem. And here n is 2 power 2e5, m is s1 equals to 1e6, same almost m here. Sum of m does not exist, sum of m does not exist, but here n is increasing. N is increasing to from 1000 to n is increasing to 1e5. You can do n, you can do n square here, but you can't do n square there. Output n integers representing the array you constructed. Can prove that in the construction such an array exists. There exists only one where all elements in the array does not exist 29. What? Who said this? It can be proven that under the under. Okay. Because here m equals to n into n power n plus 1 by 2, you have additional conditions that it can be proven that there is only one unique array. But after using this proof, you should be able to solve something like this. See, seeing an edge case, which is m equals to n into n plus 1 by 2, is giving you some kind of solution that's logically perfect, and then you're able to solve some a bit general solution somehow. See? So let's focus on D1 and just solve it like an original problem. It is. They're telling with these restrictions, you can uniquely have one. Okay. So you have these edges, n into n plus 1 by 2 edges. Okay. You have some of them negative, some of them positive, some of them negative, positive, and so on. But if you look at a cycle, what can you say? Yeah, if you look at a cycle, any cycle, and if you take alternate sum, let's look at an even cycle and let's just take an alternate sum. Okay, add this edge, subtract this edge, add this edge, subtract this edge, and edge weight is ai plus aj, let's say. Add this edge, subtract this edge, add this edge, subtract this edge will actually cancel out everything to be zero, right? So there is one restriction that for any even cycle, fuck, it's draining very quick. I'll go charge my laptop. Doesn't know nothing. Doesn't know nothing. Any even cycle W1 minus W2 plus W3 plus W4 this should be 0. Okay, this is 0. So what I'll try to do is, what did you just get? Something that involves four things is 0 is what you got, right? That's what you got. Okay, you just got this minus this plus this minus this is 0. Let me try to consider adding any other two things. Okay, now we have this thing. Now this minus this plus this minus this is 0, and keeping this plus minus minus plus minus minus plus. So this is 0 and this is 0. So let's call this x and this y. X equals to 0, y equals to 0, and x minus y is also 0, because this is nothing but x minus y equals to 0. What do I mean by that is this minus this is actually the bigger one. So you're not getting anything there. But if this happens for everything, then you're not getting anything. I was trying to say that this should be negative, and this value should be positive, and then this value should be, all of them should be positive, huh? Or doesn't know matching, or all of them should be negative. But it doesn't seem to be. It doesn't seem like it's needed. They say it's unique if it exists. So can there be a negative and positive and still the answer be yes? Yeah, it can be yes. There can be negative, positive, and still the answer be yes. N into n plus 1 by 2. Wait. If you have n into n plus 1 by 2, these things will give off their actual weight, right? Okay, this I equals to j will give you off. I equals to j will be there here, definitely. That will give you off if it is negative or positive. Somehow they are telling there is exactly one array. Wait. Oh, they didn't say that there is exactly one. That was my bad. That was my bad. Because you can always double the values, right? That was my bad. Mhm. For collapse and falling. Okay, this is not that great. I thought it's unique. That's why I was trying to say something like this. But it's not unique. They're just telling that there exists one. How did I read that wrong? I just read it like it's unique, but it's not. I don't know if I read it like that, but maybe there is one with just ones, zeros, and minus ones. When is it possible? When is it impossible? For this problem, you will know if something is if some vertex is negative or not. You'll know if some vertex is less than or equals to 0 or if some vertex is greater than 0. And with this, let's just keep all the greater than 0 this side and all the less than or equals to 0 this side first. Now what? Among all of these things, they should be less than or equals to 0 because less than or equals to 0 plus less than or equals to 0 will be less than or equals to 0, right? Among all of these things, they should have same color. Okay, now what? Now it doesn't matter much. You have this deprecating negative values, you have these things that are being positives. All of them are being positives. You have to only worry about the edges in between. This is a necessary condition. This is a necessary condition. What doesn't matter. Mhm. For collapse and falling. And now, for this problem at least, how will you solve this problem? It has good amount of solves and it's easier after you solve D1. For collapse and falling. Mhm. Oh, you don't know the values. You only know the number. You only know the number of negatives and number of positives. Can you have contradictions here, like telling this and this being positive means seems this is bigger. Okay, okay. Now you live in my dream space. Mhm. Actually, now if you try to lay all of this in an order, in a number line, you know what to do. You know what comes before and what comes after. If you want to try to lay all these things in a number line, okay, for this, with respect to this, you can know everything's relative ordering. With respect to this, everything which is like greater than 0 has values less than that. Everything is less than or equals to 0 has values greater than or equals to that. So in that way, you know everything less than this. So you're able to split them apart based on one thing. You live in my dream space, feel like in my fantasy. But how will I do when the restriction is laid off? So you have this thing. For everything, you have number of things on this side and number of things on this side. One thing you're sure is that if something has more things on this side than this side, that means this order is fixed, right? Means if some things are being like negative with something, a group that is negative can only keep on increasing with when other things comes like. So what I mean by that is this negative set. If something you said this set is negative, if something else has anything more, it should have all of these things. So these are like this kind of egg circles. Like these are all negative with something. Okay. For collapse and fall. I think if it holds on one side, holds on the other side too, then if you have something else that has anything extra, if something has anything extra, it should have all of this. But how do you define extra? Because this is extra. From okay, just let's just keep them in increasing order of sizes for now. And if this has anything extra, it should have all of that. This is another necessary condition. And you have this is another necessary condition. And once you have all these necessary conditions, then it's not that difficult to solve the problem now. What you will just do is for this thing you can just for all of these things you can just give -1, and then for this you will give like +2, and then you will just give for all of this like -3 +3 -4 +4, and then it's done. For collapse and fall. So this is an easy problem, like logical, it's not that difficult. Let me implement this because GT is having very less rating compared to this. So I'll just implement this and then I'll see. You live in my dream space. So what I'll do is see, I will find both these sets, this set and this set, and for each of this I will find its set, and then I'll sort them based on its set, which are all less than that, because it became less than or equal to it must be less than that. Okay, for each of that you have like less than that. All of them are less than that, and all of them are more of them are less than that. Means must be here. Must be here. You live in my dream space. You look at my fantasy. That's quite simple. For each of them, I'll just find their sets. I'll sort those sets in the increasing order. And then for each of the set, it should be like an increasing one. Like everything in here, everything that is been there before should be here. So you just check that everything before that should be here. And then something new can be there. You'll just check that everything before that should be here. Everything before that should be here. And then after doing these checks, okay? After doing these checks, okay. Oh, you live in my dream space. Relook at my fantasy. I was just thinking, what if this is like same set and this is also like the same set? Then can you just give -1 here, +1 here, -2 here? Yeah, you can do that. You can do that. Only when set size increases. Because if they're the same set, okay. You can just do that. For the new things that came here, you'll do -2. It just works. For the new things, -1, +1. For the new things that came here, you will do -2. If nothing new comes, nothing happens. Yeah, you can keep doing that. That works. That just works. That just works. That just works. So I'll collect positives and then I'll collect negatives with respect to them. And then I'll just lay them. You live in my dream space, relic in my fantasy. Let me just take them as adjoint itself. By chance, I solve the next problem. It will be convenient. You live in my dream space. But you see, this you can't even maintain. No, no, no. Just not think about this. Let me just do this problem. You live in my dream state. Mm-hmm. I stay in reality. You live in my dream space. I don't worry about the other thing. Let me just do this thing. Whatever simplest, I'll just do that here. Less of n plus 1. So these are the less groups, let's say. For each of them, I'll just maintain. Things that make them negative. These are positives. This is type. Type equals to 1, that means it's positive, right? If x equals to y, what I'll do is means greater than or equals to 0. Positive means non-negative. I wrongly assumed these things wrong. So now, if these are non-negative, if these are greater than or equals to 0, if this is greater than or equals to 0 and this is less than 0, okay? Now, if everything will become... Yeah, even now I can identify if something is less or something is... And then what I need? For negative things, I want... So, this is a non-negative one. And then it made it negative, means it must be bigger. It must be bigger. What does this means? Like, a of y greater than a of x if x is positive. I could have done the other way too, but let me try to do it like this. So for all the positives, you have some groups which are bigger than them, which can actually greater than or equal to 0, but it became less than 0, which means these are like big in value. Okay. You live in my dream space. So what will I do now? I will sort them by sizes, let's say. Okay. We will get things which are bigger in magnitude. Okay. Okay. Oh. You live in my dream space. You look in my fantasy. I stay in reality. Let me also collect edges. This is too much. This is too much. I'll just do this instead. You live in my dream state. Now what? Let's just say whatever is in group. These are like bigger things, right? I'm coming from bigger things, which is a bit bad. Okay, we have some curve. and I'm trying to give lesser and lesser and lesser values. Okay, what will I do is, for these things I'll give like, I'll just do these checks first. Okay. Now you have these clusters all positive, cluster all negative. Now I'll just start with the, for negative thing, the smallest size. That smallest size will take, or I can start with the biggest size. Sorry, the smallest size will take maximum value. Okay. If non-negative is empty, means all of them are negative, then what can you do? You can just keep -1 for everything, right? Okay, you now have this thing. So now what I will do is, for that group 0, so in non-negative 0, I'll try to find it less. It's actually not less, it's actually greater, but fine. It will make it negative. It will make it like, for all of this, I'll try to give this maximum value of cur. It should be, you live in my dream state. After this, I'll do cur minus minus. So all of them got some big negative. Now, what should I do? I had to put non-neg of 0 to be cur. Now, For all of this, what you should do is you have to verify that everything that has came before has occurred now. Okay? Which means you have to verify that. Let me just do it like this. So everything is in the current group I kept X. Now I'll try to see the previous group, okay? Now everything in the previous group should be here. Now came of v equals to 1 will be for the new things that have came, right? Now what I'll do is I'll just keep the non-negative because they're new. I'll give them cur. It's negative cur. And then I'll do cur minus minus again. And then what will I do? You live in my dream space. Lost in reality. You live in my dream. Actually, I have to go in the order of groups. I fucked up again, huh? This can be right if I was you. Mm-hmm. S, no, no. If I was you. Du-du-du-du-du-du. What is it? Two comma two should be negative. What happened? Now what I should do is if any negative things are left out, I had to put a minus on that. This makes everything perfect, I believe. Because all positives are marked. First negative has been marked, which is like bigger than this. And then everything has been marked. Even if some negatives are smaller, yeah, I have to mark them negative too. All positives are marked. You live in my dreams, stay. You look at my fantasy. I stay in reality. You live in my dreams, babe. Can I get a kiss? And can you make it last forever? Somebody go to war. I don't even know I'm seeing you. I don't know if I'm seeing you. You live in my dream street. That can be one runtime error because I'm not putting both of them. I stay in reality. Every time I fuck up. Oh, 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 oh. Mm, 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 mm. You live in my dream state. You live in my dream space. You look at my fantasy. I stay in reality. I don't know. This is not intermediate for me. You live in my, you live in my dream space. Look at my fantasy. I stay in reality. Mm-hmm. You live in my dream, you live in my dream state. Look at my fantasy. I stay in reality. Mm-hmm. For collapsing falling. So annoying. Why is it wrong? Everything is right. You live in my dream state. Look at my fantasy. I stay in reality. Gotta kiss. I was singing some other song. What was that? Fell in love, but he left me lonely. Tried to, tried to trust, but it left me. Tried to trust, but it found me slowly. I didn't know what I was looking for till I found her. I found her. Something like that will come. To live in my dream space. I stay in reality. I stay in reality. You live in my dream space. Huh. They kept so much of memory, so it can be a random error. It can be a random error. You live in my dream. You live in my dream state. Fell in love, but it left me lonely. Tried to trust, but it found me slowly. Didn't know what I was looking for till I found her. Is it even worth it if I'm getting stuck on these stupid problems to do this? Because this one I have solved it totally. Like, I don't see an error here, and even this I don't see an error here. Fell in love, but it left me lonely. Just, but it found me slowly. Fell in, fell in, fell in love, fell in love, but it left me. Fell in love, but it left me lonely. Tried to trust, but it found me slowly. I didn't know what I was looking for till I found her. I found her. Fell in love, but it left me lonely. Tried to trust, but it found me slowly. I didn't know what I was looking for till I found her. I found her. I'm not even visible, I think. Right again. Fell in love, but it left me lonely. Tried to trust, but it found me slowly. So fucking annoying. What am I missing? I didn't know what I was looking for till I found her. I found her. Where is it? Some things that are left. I'm trying to paint them minuscule. Wait. What is this? No. Vals. Fell in love, but it left me lonely. Tried to trust, but it left me. In love, but it left me lonely. Tried to trust, but it found me slowly. Didn't know what I was looking for till I found her. I found her. Let me assert. Let me do some assertions. Mm-hmm. Fell in love, but it left me lonely. Tried to trust, but it made burning. I didn't know what I was looking for till I found her. I found her. Oh, even before it was runtime errors. Maybe this val equals to n is a setting. One quick way to now just comment down the asserts and then submit and see if you'll get wrong answer this time. Love, but it left me lonely. Tried to trust, but it left me far. Tried to trust, but it found me slowly. I didn't know what I was looking for till I found her. Okay. You live in my dream state. Relook at my fantasy. I stay in reality. 1 plus k minus 1, which is k. And then, now its value is k plus 1. And I have to go from da, da, da. You live in my dream state. Relook at my fantasy. I stay in reality. The love, but it left me burning. Felt like love, but it left me lonely. Tried to trust, but it left me burning. Felt like love, but it left me lonely. Tried to trust, but it left me burning. I didn't know what I was looking for. I didn't know what I was looking for. Till I found, oh, we had to start from one, I think. We had to start from one. No. I was right. Zero should go in there and then to start val plus plus. You live in my dream state. Relook in my fantasy. I stay in reality. You live in my dream state. Am I wrong somewhere? You have 0 to z minus 1. So this will be z minus 1 if you rearrange them. Index z minus 1. And then what will be this index? This index will be 2 power b minus 1. If you rearrange them because you have everything that's needed in there except 2 power b minus 1. So I have idx equals to 2 power b minus 1. And then I have, you live in my dream state, relic in my fantasy. I stay in reality. I'll say if this is the one that's failing. I should be a bit more careful. So let me enable both of these things so that I don't do three. Wait a minute, doing this is better. First, doing this is better, maybe because it's just one thing. So I'll know if that's what the assert is from. Wait. What is this I plus one? That's right. Love, but it left me lonely. Try to trust, but it left me burning. I didn't know what I was looking for. Let love, but it left me lonely. Tried to trust, but it left me burning. I didn't know what I was looking. I didn't know. I didn't know what I was looking for. Till I, till I found her. Fell in love, but it left me lonely. Tried to trust, but it left me. Tried to trust, but it left me slowly. You're in my dream state. I'll see if this is the error. Look at my fantasy. I stay in reality. Yeah. Mm-hmm. Mm-hmm. Oh, it should be plus one, right? Because that has been filled already. No. Okay, till here it's right. How the fuck it's going wrong from here now? Mm-hmm. I stay in reality. There's no wrong here. There's no error here. There's no error here. RDX is obviously greater than or equals to. You live in my dream state. Really look at my fantasy. What if z equals to idx minus 1? Will that cause some issue? If z equals to idx minus 1. Z equals to IDX is possible, right? Not case this doesn't happen. Fell in love, but it left me lonely. Fell in love, but it fell in love, but it fell in love, but it left me lonely. Try to trust, but it left me. Try to trust, but it was slow. Fuck is wrong here? I don't really give a damn about the way you touch me, and we're alone. You can hold my hand, and no one you like it when I'm away. Fell in love, but it left me lonely. Just trust. I'll do that one more assert. Fuck, it's done. So sad that it's done. Leave.